Today we are going to discuss about the function and its diagram. For your preparation is a review. Now here we have the quadratic expression, that is 2x squared minus 8x plus 11, and the question asks you to write down this form becomes 2 times x plus a squared plus b, where a and b are constants. So to do these questions, you need to write down the expressions. Here we have 2x squared minus 8x plus 11. Now you need to factorize the coefficient 2 from 2x squared minus 8x, and it becomes 2 times x squared minus 4x close plus 11. Now, for doing the next step, you need to remember that if we have the quadratic form of x minus 2, which is 2 comes from here, minus 4 divided by 2 is minus 2. And if you square this expression, you will get x squared minus 4x plus 4. In other words, you can say that the x squared minus 4x is equal to x minus 2 squared minus 4. You can substitute these expressions with this one, and then the equation becomes 2 times x minus 2 squared minus 4 close plus 11. After that, you can do the rainbow multiplication to simplify this form, and it becomes 2 times x minus 2 squared, and then 2 times minus 4 is minus 8 plus 11, and then the final answer is 2 times x minus 2 squared plus 3. Here we have the similar form for this 2 times x plus a squared plus b, which is they are congruent. Okay, and then you can say that a with is equal to minus 2, or you can say that a corresponds to minus 2. So you can say a equals to minus 2 and b corresponds to 3. You can say that b equals to 3. So this is our answer for the questions part A. Alright, now we can go to the next step. Here we have the questions part B, and given the information that a function f is such that fx is equal to the previous quadratic expression that we have handled it, that is 2x squared minus 8x plus 11, for the domain x is greater than or equal to p, where p is the constants. And you need to know that this domain can be exist if the inverse of this function also exists. So the first thing that you need to do in this question is you need to find the inverse of this function, right? So let y is our function such that the y is equal to 2x squared minus 8x plus 11. Okay, and we know that this expression can be simplified, becomes x minus 2 squared times 2, all right, and do plus 3 here. Okay, after that, we can subtract both sides by 3 to make the x minus 2 squared here alone. Okay, and then we get y minus 3 equals to 2 times x minus 2 squared. To make it more clear, we can change the position of the 2x minus 2 squared, becomes 2 times x minus 2 squared on the left side, and the y minus 3 on the right side. Okay, and then we need to divide both sides by 2, and then we get x minus 2 square equals to y minus 3 over 2. After that, to eliminate the square here, you can take the square root for both sides. You can apply the square root both sides, and then you will get x minus 2 equals to the square root of y minus 3 over 2. After that, we can make this x here alone on the left side. That is x equals to the square root of y minus 3 over 2 plus 2. Okay, after that, we can say that x is our inverse for the fx. We can denote the symbol of inverse fx like this, and then it is equal to the y becomes x, domain for the inverse, and then minus 3 over 2 plus 2. Okay, and then we can see clearly that the domain of our inverse function here, the expression inside of this square root must be always positive or 0. Okay, you can say that x minus 3 over 2 is greater than or equal to 2. In other words, we can say that x is greater than 3. Okay, sorry, this is greater than or equal to 0, and the domain for this inverse is x is greater or equal to 3. Okay, you can simplify this. And then when we see the domain, the minimum value of 4x, here we have x equals to 3. When you put in this x equal to 3 into this function, you will get the minimum function value is 2. It means the range of this inverse y must be greater than or equal to 2. You know that the function of the square root has the property increasing monotone. Okay, it always be positive and increase. So we denote the symbol of the greater or equal to 2 in this case. Now we can say that if we have the range y is greater than or equal to 2, it will be related with the domain of our origin function. It means since our range of the inverse is y is greater or equal to 2, we can conclude that our domain for our function must be x is greater than or equal to 2. In other words, the value of this p corresponds to 2. We can say that p must be equal to 2. So that is our answer for the question part B. Okay, next we can go to the part C. Here we have the questions, and the question asks you to sketch the graph of y equals to function fx and y equals to the inverse function fx. And then don't forget to label its graph and then state the intercept of each of the graph with the axis. Okay, so our focus here, we have to concern to this value of p. This is our domain, right? So the first thing that you need to do is you need to evaluate the coordinate of y equals to 2x squared minus 8x plus 4. Alright? And then since we can simplify this one becomes y minus 3 equals to 2 times x minus 2 squared. They are congruent. We know that. So we remember that in this form, in the general form, y minus k equals to 8 times x minus 8 square, this general form gives us the information, the location of the vertex point. Okay, we know that this function has the graph model in the parabola because the coefficient of x squared is positive, that is 2. The parabola model is like open up parabola. Okay, the shape must be like this. Okay, so this is our vertex. This vertex point, let's say xp comma yp, can be find by put the value of h and k. In other words, here we have h corresponds to 2, k corresponds to 3. In other words, the vertex points of this function is 2, 3. Okay, so that is our vertex point for the function f(x). Now we can go to the intercepts. Okay, now let's try to find the x-intercept. Okay, so to find the x-intercept, you must put y equals to 0 to find the value of x. But before doing that, you have to check the discriminant or the determinant of this function first. Let's say we have d equals to b squared minus 4ac, right? And we can say that a is 2, b is minus 8, c is 4, and then you can put that numbers, that is 64 minus 4 times 2 times 11. Sorry, I need to fix this. The equations give us 11, not 4. Okay, and you get 4 times 2 times 11 is 88. All right, and then you get minus 22. Since the discriminant is less than to 0, it means there is no intersection on x-axis. Okay, so that is our findings. You don't need to find the x-intercept because we see that the discriminant is less than to 0, so there is no intersection on x-axis. Okay, so next we can go to the y-intercept, right? The y-intercept here is x equal to 0. So you need to substitute the x equals to 0 to the function, and then you get y equals to 2 times 0 square minus 8 times 0 plus 11. So y must be 0, 11. Okay, so the coordinate of y-intercept is 11, 0. But remember, since our domain of function must be greater than or equal to 2, so our conclusion that x equals to 0 is not belong to the domain. So in this graph, we don't need to draw the location of y-intercept. Okay, and to draw the curve, you need to put two values of coordinate minimal. Okay, so I take uh, a table. Here we have x and y. So if I put x equals to 2, you get the y value is 3. Okay, and then if I take the value of x is 4, and the y must be 11. Okay, so that is our coordinate to draw or graph on this Cartesian diagram. Okay, now let's make this diagram with numbers. Let's say I have here 2, 4, 6, okay, 8, 10, 12, and so on. After that, here we have, sorry, okay, we can draw here 2, 4, 6, 8, 10, 12, and so on. Make sure that the distance between these numbers are equal, okay, and proper. Now we can put the coordinate 2, 3. So the location must be here, 3 on y, 2 on x. So the coordinate of this point is here, 2, 3, and then 4, 11. So the coordinate must be on here. 4 and 11 must be on here. Okay, make sure that you use the ruler to make the graph more proper. Okay, so we have the curve like this. I will draw on with the blue color like this. Okay, after that, let's continue to evaluate the graph on y. Evaluate y equals to the inverse, that is the square root of x minus 3 over 2 plus 2. Now, for this one, you need to remember that the domain of this function, the domain of the inverse function fx, x must be greater than or equal to 3. So you can start the point from x equals to 3. And then to find the other point, you can make the table like we do before. Here we have x and y, okay, and we start from 3. If you put x equals to 3 to this function, you will get the value of y is 2. After that, if you put, we want to try to find the integers here, so I choose 5 for the next numbers. And then if you put x equals to 5 in this function, and then you will get the value of y is 3. Okay, so let's put the point 3, 2. So the position 3 must be on here and 2 on here. So this is the point of 3, 2. Okay, after that, the position x5 must be on here, and then 3 must be on here. So let's draw the position of 5, 3. So this is the position. Okay, after that, you can draw the curve by using the red color to differentiate with our function fx. So the function must be like this. Okay, you can see that this is our function of fx, and this is our inverse function fx. Alright, so that's all for this example. I hope you can understand for the concept. Please do the exercise so you can understand these questions more fluently. Okay, thank you for your attention. Bye bye.